All right, how's everyone doing today? Welcome to the moon and back. As you can see, we are doing class a little bit differently nowadays, and we're actually out in what I'm calling the fabric of space-time. As you can see out here, a nice old pool table, of course occupied by my lovely friend Sir Mr. Finnekins, who hopefully will help us explain some of the stuff we're going to get into. However, before we get too deep into everything, we want to go ahead and make sure that we are all here. So we're going to want to take roll. So, Cosmo, are you here?
Here,
Excellent. Andromeda?
here,
Excellent. Galaxy?
here,
All right. Luna?
here,
Pluto?
here.
Pluto's not here. Oh, you are here.
I'm here.
I thought they kicked you off in the planet core.
No, I'm still here.
Excellent. All right. Well, Pluto is still a planet as long as you're in my class, I suppose.
Yay.
Seeming that you're here. I don't want to kick you out just yet. All right. Anyways, what we have right here on this red fabric is my version of space-time. What is space-time? Space-time, you can kind of vision it as a piece of fabric where all of the different planets and suns all just hang out. As you can see, they just all hang out and sit here right on top. And it's called space-time because it's where the matter that is made of the planets and time, what we experience is the movement of our experiences. Today is today and tomorrow is tomorrow, kind of converge. And Einstein theorized that they converge in kind of this fabric-y concept, and that this fabric itself is distorted by different energies. And so I have this. And the first thing we are going to go ahead and talk about is gravity. Well, what's gravity? Gravity is the force that attracts one object to another, so they can be friends. So let's first start off, does this work on this perfectly flat pool table if I roll one planet, the number 4 planet, across the cue ball? Will it start to go towards it if I shoot it nice and straight? If I shoot it nice and straight, will it go towards it? I don't think it did. Let's try a golf ball. Let's try a golf ball. Does it go through it? No, it doesn't. And the reason why is because this flat surface is not allowing the energy of the cue ball to actually distort the fabric of time. So, to get a better understanding of actually how it works, we have to have something that actually allows the mass and density of an object, or the energy it has, to distort it. And so to do that, we're gonna have to do a little bit of a time warp. So go ahead, hold on to your britches, and we're going to quickly grab all of our stuff, and we're gonna time warp inside.
Bloop, 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 bloop.
All right, I'm glad we all made it. It was quite a long travel from outside at the pool table to inside right here. And if you can see nice and close, go ahead, come up and nice and close. This is our new version of our space-time fabric. And the cool thing about this is that we can have gravity actually work the way it's supposed to. So if I place something on here just like this, and we go ahead and we have another object. This has mass, which is, what is mass? Well, mass is basically how large something is. And so, because it has mass, it is distorting the space-time. Which means if I roll this right across it, instead of going nice and straight like it did on the pool table, it should curve. Look at that, we saw it curve.
Ooh.
And it actually came right back towards it because it's distorting space, and so it's pulling it closer. And they're attracted to each other because of the way that their presence is distorting space-time. Let's go ahead, let's see it again. That's pretty good. Let's go ahead, let's see if we can try maybe a few of them, and let's see if we could get them to go into an orbit where they're traveling so fast that they continue to go around and around and around. All right, that was pretty good. We got almost a whole orbit there. I'm gonna go ahead and I'm gonna try again with all of them. Well, you can kind of imagine these. This is the sun at the center of our solar system, and here are some planetoids that are gonna start going around and around and around. All right, that was pretty good. What you'll notice there, I'm gonna do it one more time. Make sure we can see this nice and close. Watch where all four of them go. They're gonna stay close together. Not only are they going to want to get nice and close to the golf ball, they themselves are going to want to stay together because they're distorting space-time as they move. And so they're pulling each other close together. You'll notice they kind of start a little bit away, and then by the end, they're nice and close to each other. Let's try that again. Make sure we're nice and close on that too, if we can. All right, here we go. Look at that, separated. And eventually, by the time they get all the way there, all four of them are nice and touching. So that is because they're distorting space-time. Now, let's go ahead and talk about something like this. Is this distorting space-time? It is. It is. It's got a lot of mass to it. It's got a decent size to it. It's occupying a lot of space, right? It's occupying a lot more space than this golf ball. But let's go ahead and let's try the marbles. We're gonna try it here, and we're gonna do one. Okay. I threw it pretty good. It went all the way out, and then it kind of curved around, all the way out, and then curved around, all the way out, and curved around. But let's use something like the actual cue ball. So I got my number 6 cue ball. Let's use the cue ball, and let's think, what's gonna happen? Is this going to distort more space-time or less space-time than the foam basketball? The foam basketball is quite of big, it occupies a lot more space, but there's something different about this. Look at that, look at that. Go ahead, come nice and close, nice and close, nice and close. You'll notice, as I place it down, it's distorting space-time so much more than basketball. Because it's dense, it's density. And density is how compact something is, I could take this, I could squeeze it. I can squeeze it a whole bunch, and there's air getting sucked out of it. And I put it in a vacuum and sucked it up, it would get a lot smaller, a lot smaller. This, on the other hand, is already very, very dense, and it would be difficult to make it more dense. So let's look at the difference when we throw some marbles on this one. Remember last time on that basketball, it went straight out and then it came straight back. This is distorting it a lot more. I'm thinking that the marbles are going to be attracted to it a lot quicker. Look at that. You even get a better orbit with it. I try to run it straight across it. Oh, look at that. It's got a big jump. It pulls it really big to the side. Really big to the side. Oh, we even got kind of an orbit going the opposite way. Really big. Throwing it straight, and watch how much it curves. Straight. Nice big curve. We're gonna go back just so we can see it now. You're gonna see it now. I'm gonna throw it straight across. Look at that. It goes all the way off. threw it the same strength, and it went off because I threw it nice and straight. Again, nice and straight. Okay, that one I didn't throw it quite as hard. You'll see it comes right up and it comes straight back because it doesn't get that curve. It doesn't have that nice curve because it's not being pulled. It's not attracted as much because it's not as dense. And because it's not as dense, it's not distorting the fabric of space-time as much as the very dense cue ball. There we go. All right, now I'm gonna go ahead. I'm gonna put this cue ball in here. I'm gonna leave it in there. And I know you guys have all been waiting. What happens if I just throw a whole bunch of marbles in here? So why don't we go ahead and do that? I got a few back here. I even have some as some different size marbles. Some different size marbles in here. Let's grab a couple more. Just in case you want to see more videos of this is called a gravity well. It's just some like fabric-y spandex. I'm sure you can find other videos that you are going to talk about this. Mine is kind of small. You might be able to find some other YouTube videos that have some really big ones in there. All right, so got a few marbles. We're gonna throw them out to the side. Let's see what happens. There we go. You'll notice once again, they all clump up. Oh, and then we had that one at the very end kind of hang out. Now we're gonna try one last thing. We're gonna try one last thing. I'm gonna try to do it. Now we all know that I broke my hand. As you can see, the cast is off. The cast is off, but it's really stiff. This is about as much as I can I can squeeze it right now. So I'm gonna be working on that. But what we're gonna try to do is I'm going to try to throw marbles one direction and marbles the opposite direction. And the reason why is hopefully, I don't know if our gravity well is big enough, but what should happen, if I can get marbles into my broken hand here. Whoop, all right. What should happen is that eventually all the marbles will be going one direction, just like the band, but a little bit different. They should all be going one direction as they collide with each other. All right, here we go. All right, you can kind of tell at the very end right there, the last ones that were moving were all going in one direction. And that is an example of why when we look at our solar system, all of the planets are all traveling in the same direction. They're all traveling in the same direction. And when we look at other solar systems, most of the time, most of the planets are all traveling in the same direction. At least if they were all planets that were created at the same time as the solar system. All right, so we're gonna go ahead and move on from our gravity well. And we are going to talk about the Apollo missions. Now for that, I have my own little rocket that I kind of made with my hands, which was kind of difficult to make because this one doesn't work so well. But anyways, I've got some fins on here. As you can tell, I just kind of duct taped them on there. I used a soda bottle, Dr. Pepper. You know, I like Dr. Pepper a lot. I actually, as you can tell, this is the side that you could fill up with water. I just used a second one, cut it off, and put it on top, so I had like a nice nose cone. And the reason why we're talking about that is because I'm going to give you a little bit of homework. But before we get into what your homework is, I know you're like, oh no homework. We're going to do a little bit of history. We're going to talk about the Apollo missions. The Apollo missions. To get there, basically, the Apollo missions were NASA's missions. They called them the Apollo missions, and those were the missions designated to get a man to land on the moon, put their feet down, and get home safely. Obviously, that safety part is very, very important. Now, the rocket that they used to do that, they called it the Saturn V. And you can see I wrote Saturn V up here, and I have a V instead of an actual 5 because they like to be weird and use Roman numerals. So it's the Saturn V. It was used by NASA in 1967 to 1973. It was a 3-stage rocket, and I know we've talked about staging before, and we're going to come back to that. But basically, staging is the idea that your rocket goes up, and then once it has run out of fuel, you drop that excess engine off, and you use another engine, smaller and smaller and smaller. It is the tallest rocket ever produced. Ever produced. It is the tallest rocket ever produced. And it was used, like I said, in the Apollo missions. Now, the first few times they tested it during, Apollo 1, Apollo 2, Apollo 3, they're testing it. They're doing different things. They're sending it up, making sure it orbits, just like we were doing in class when we started by orbiting around the Earth, and then orbiting around the moon, and then actually landing, which we haven't gotten to yet, but we'll get to. The Apollo 11 mission was the first mission where they actually took their rocket and landed it on the lunar surface. Now, the funny thing is that it carried 3 people. It carried Buzz Aldrin, Neil Armstrong, and Michael Collins. However, only two of them actually landed on the moon. Because if we imagine this as the moon, it's really hard to hold. We imagine this as the moon. While they're orbiting around and around and around, they had 2 stages on this. They had the lunar module and their command module. And what they did is, I've got 2 marbles to represent that. I've got my command module and my lunar module. They took the command module and they left it orbiting. I'm going to put it down, but pretend it's orbiting. But the lunar module that Neil Armstrong and Buzz Aldrin on, they took it down and they landed it on the lunar surface. And they got down there, and that's when you hear him say, one small step for man, one great big leap for mankind. I might have misquoted that. You could correct me if I'm wrong. And they landed down there, and then they took that all the way back up. They connected with, whoops, I'm horrible at this, one-handed. They connected back with the command module. They said, hey to Michael Collins, who was like, I didn't get to go see to the moon. He just got to hang out there all by himself, kind of probably very, very lonely. Said hi to him, and then they took that lunar module and they dumped it back off. And they took the command module all the way home. And then that's what they landed in with their parachutes, what have you. So, your homework is to make a rocket out of materials from your house. As you can see, I use some different materials out of mine. Now, this is only a 1-stage rocket. I can't pull it apart. I'm going to give you the challenge to make a rocket that has at least 2 stages. So you could say the bottom half is the first stage with its rockets, its engines. Use toilet paper rolls, use cardboard, use construction paper, use your mom's favorite plastic glasses and glue them together. Okay, don't use your mom's favorite plastic glasses, but you get the idea. Use something and make it into a rocket that maybe you scotch tape, and then when it does the next stage, you could just take it off, and then you have that second stage. And you can make your own model from it. Try to do 2 stages. Definitely do 2 stages, but try to do 3, just like the Saturn V. Okay? Other than that, I think that's all we have as far as some history. But I'll tell you what, let's do the gravity well one last time. Now, I've already got some stuff in there. I'm gonna go ahead. I'm gonna leave that 6-ball in there. I'm gonna put it back in. I'm gonna put some of these in my pocket because I can't hold them all. I'm gonna put that in there. I'm gonna grab a golf ball this time. I'm gonna grab some of those big marbles. And come on up real nice and close with that camera. Bring that camera all the way up, nice and close, nice and close, nice and close. And let's go ahead and let's see if we can get some extra solar battles between the planetoids on this one. Here we go. There we go. And as you see, as they all get nice and close, they pull and sink down space-time and they distort it even more. And eventually what happens, if they all get nice and close, they'll get so dense. That's how we get a planet with all of our different stuff. All right, one more time. Some more marbles. Let's go the opposite direction this time. There we go. We even lost some outside. All right, make sure you do your homework. Take a picture of it, take a couple pictures of it, and then send it to my email so I can take a look at them. And hopefully I'll be able to post them and we can all take a look at everybody's. Other than that, good luck.